Assalamu alaikum. Welcome to another session of data structures and algorithms using C++. My name is Dr. Bilal Wajid, and today we're going to talk about fundamentals of pointers. Now, pointers is really a type of variable that points to another variable. Now, point to fundamentally means that it actually stores the address of the other variable. So here is an example where a is an integer. So once we declare a to be an integer, there is a space in the memory which is allocated to an integer and that space has its associated address. Now when you assign a number to that variable, that number is assigned fundamentally to that address. So this particular address holds the value 10. This is how we declare a pointer. So b is a pointer which can point to a variable of type integer. So the asterisk helps within the declaration to tell us that b in fact is a pointer. The data type really tells you which particular variable this pointer can point to. So integer asterisk b. So then there is a location in the memory which is allocated. b is a pointer because it's been declared with this asterisk. And when we say b now has been assigned the address of a, remember a pointer points to another variable because it stores the address of the other variable. So here we're saying that b has been assigned the address of a, right? So you're going to so whenever in English you would actually refer to this ampersand, but here you're going to refer to it as the address. So the same way in English, in mathematics you would call this equal to. Here in C++ you actually refer to this as assigned to. So the way we're going to call out this particular statement, we're going to say b has been assigned the address of a. So you see here the value of b actually got updated. It is has been assigned 0x, which is a representation of hexadecimal. So this number 100 is not the decimal 100, it is actually the hexadecimal 100. So the same address as a is now actually being stored into b, and because of that it now becomes a pointer, and it is pointing to a because it holds within it the address. Now because of this you can now directly access a through this pointer b, and this is going to become extremely useful to understand because arrays, we used pointers to point to arrays, and it was one of the reasons why pointers came up with, because it was not easy to pass on an entire array onto another function, as we discussed in the last lecture. So now b has been assigned this address. So whenever you want to print out the value of a, you normally write cout a has been assigned, and you put this, and this will actually give you the whatever is a. In this case it's going to print out 10. But the other option is now you can access this a using this asterisk b. So here you're going to refer to it as contents of the address b. So b is the actual address, asterisk will over here refer to as its contents. So the address is this guy, and what are the contents of this location? Well, it's 10. So in both cases 10 gets printed. Right? Now you can also print out the address of a by simply asking you to give out the output b, because b holds it within it the address. But you can also do it with this, which is the ampersand address of a. So these both, because remember b has been assigned address of a, so both of these elements will give you the same value. Okay, so let's look at this by running this program in cpp.shell. So if we go on to the shell over here, this is our program. When I press run, right, notice a has been assigned as 10. That's what we wanted here. And then we said print the contents of the address b. Now again 10 is printed, and this is the address of A. Print the address of A, and we see the same hexadecimal value, which is the address, and again we are printing B, which again holds the same address, right? So now going back to the lecture itself, another important thing to discuss here is the null pointer. The null pointer is a good default value, and it is defined in several libraries, including the input output stream. So technically it points to the location 0. It doesn't mean it is 0, it points to the location 0. The location 0 can contain something, but it is very useful in fact in checking whether a pointer has been initialized or not. Now this is going to become very useful when you talk about files. When you want to access a file, or if you want to, let's say you want to, there's an external file, you want to pick some data from that file, we're going to use file pointers over there. Now it is useful because this, you can use this and these two if commands. So if pointer, which technically means this will run successfully if pointer does not equal to null. In other words, that pointer is really pointing to something. And if not pointer, now this will be successful if pointer is equal to null. In other words, it's really not pointing to anything. And here you can kind of like put some statements which are, you know, a graceful exit. You can say, sorry, the pointer is not pointing to anything, so I can't really do something. So you can then exit and return out of the function. Using this null pointer, which is, you know, a capital NULL, it's very useful in avoiding accidental use of uninitialized pointer. So as an example, right, let's try using this as an example. Here I have this function which I've written down, and here when I say integer pointer B, I've also said pointer C has been assigned to null. When I run this, right, we can see here the contents of C are actually pointing to address location 0. Okay, so once again, I hope this lecture was very useful. Remember to try these programs before moving on to the next lecture. Okay, until next time, thank you very much. Bye bye.